This is the feasibility and environmental impact study for the proposed North County desalination facility. We are BAGG Environment, and we hope you enjoy the conversion of seawater to freshwater as much as we do. The project site falls into San Diego County Water Authority's target location between Oceanside on the south and the San Onofre Nuclear Generating Station to the north. The plant will have an initial capacity of 30 million gallons per day, MGD, of fresh water output. The facility will include marine intake structures, horizontal wells primarily, for seawater intake and the resultant saline concentrate outflow leaving the plant. The proposed site on Camp Pendleton was chosen for its proximity to existing power and water grids, for its adequate soil conditions, and for its sufficient coastline of 1.7 miles to accommodate the horizontal wells. The Camp Pendleton government land also provides access and facilitates quick construction of the desalination facility. The geotechnical investigation found no active faults run across the proposed site. The biggest threat to the site comes from the offshore Newport-Inglewood fault, capable of a maximum earthquake magnitude of 6.9. The soil borings for this site were assumed under SPT analysis to be the same as those of the Oceanside High School Performing Arts Center, which is located roughly 5 miles to the south on comparable soils. The USGS deaggregation plot gives us a 475-year design return period in which the peak horizontal ground acceleration will be 0.27 g. The geotechnical recommendations and findings are given below, with the main points being a 0.27 g design maximum acceleration, negligible liquefaction with the absence of a groundwater table, and the spread footing allowable bearing capacities are given below. BAGG Environment also conducted a road study to determine the feasibility of bringing in a paved road to the North County desalination facility. The proposed extension is 1.3 miles long along existing dirt firebreak and access roads. This should minimize the impact on the environment. This road will connect with Interstate 5 at the Las Pulgas Road exit and should provide for the assumed roughly 200 average daily trips to and from the plant between construction and operational phases. The shown figure represents a basic flow chart for the North County desalination plant.
The San Diego County water supply system consists of imported water and local water supply facilities. Currently, San Diego County imports 80% of its water supply, 50 from Colorado River, 30 from seawater projects, and the remaining local water includes surface water, groundwater, conservation and recycling. Water demand. Water demand projection provides the basis for evaluating of future water supplies. Based on our findings, water is likely to be the most critical challenge that the San Diego region will face during the next 2 decades. Desalinated seawater is the future source. It's expected to be 10% source of the regional water supply by 2020, which is about 80 MGD. 50 MGD of this goal would be made by the Carlsbad Desalination Project. The next augmentation of seawater desalination up to and beyond the 80 MGD is the goal of this study. This figure shows the historic and the projected demand of the San Diego County region. Based on hydrological soil formation of the proposed site, high yield volume capacity, construction cost, and lower environmental impact, horizontal well intake is recommended for this project. In order to produce 30 mgd, a total flow of 90 mgd is required. Horizontal well intake construction would include installation of a total of 23 wells. Each intake well has a capacity of 5 mgd. Caissons will be constructed from reinforced concrete, wall thickness of 2 feet and inside diameter of 30 feet. Pipe layout. The collector pipeline will be constructed using the conventional cut and cover trenching methods, as shown in a figure. BAGG Environment recommends the following pipe sizing. The following tables summarizes the proposed pump requirement to convey feed water to the treatment plant. Discharge, hydraulic, and environmental design. Prior to disposal of the waste into the ocean, dilution is required. This plant will have a dilution tank and diffuser to do so. The table summarizes the recommendation made by BAGG Environment for the plant to achieve its goal.
The desalination process starts with pretreatment, which is intended to remove large biological flux from the influent water and prevent pipe clogging and membrane damage. The components to our pretreatment process are pre-screen, coagulation and sedimentation, pretreatment membrane filtration, cartridge filtration, acidification, and scale inhibitor. This is the pretreatment process diagram. After the water is desalinated, it must go through the post-treatment process for disinfection and remineralization before distribution to the county of San Diego. The components to post-treatment process are lime addition, recarbonation, corrosion inhibitor, disinfection, and aeration. Although our alternative options for remineralization are calcite bed filtration and water blending. The storage tank will be needed to store and distribute drinking water to the county of San Diego. The design dimensions are based on the population consumption rates and fire flow requirements. And our proposed dimensions for 2 storage tanks are 20 feet for the depth and 36 feet for the diameter. Waste management is essential to safely store and dispose of water and chemicals used to clean the membrane. When treating sludge collected from pretreatment membrane filters, backwashing and solid dewatering will be commonly used. When cleaning reverse osmosis modules, chemical rinses will be done to remove sludge from membrane. The chemical and sludge will be collected into a storage tank on site and will be sent to a nearby solid waste treatment plant.
Plant power requirements and electrical supply options. A preliminary analysis of several electrical supply options were evaluated, and the following options are recommended. Electrical energy provided by San Diego Gas and Electric, on-site self-generation using solar power. The following table summarizes the solar energy calculation for the project. We found that for the project we need 1,676 total panels, which is going to produce about 1,843 megawatts a year. The total cost for the panels about 1.5 million. Cost development. The cost developed for this project include capital cost, operation and maintenance costs. The capital cost. The following parameters were considered in our approach to the project capital cost: seawater intake, concentrate disposal, desalination facility, electrical power service. The following table summarizes the capital cost for the project. We estimated the cost to be $180 million. The following assumptions were made to evaluate the operational and maintaining costs. The following table summarizes the operational and maintenance costs. We estimated the annual operational and maintenance costs for North County desalination project to be about $19 million. Okay. Table 7.4 summarizes the water cost for North County desalination. The capital cost estimated to be about $180 million. The O&M cost estimated to be about $19 million. The water produced estimated to be about 32,000 acre-foot per year, and the water cost per acre-foot were estimated to be about $1,016.
In addition to the feasibility study, BAGG Environment also studied the environmental impact and mitigation measures that would result with this project. The integrated environmental impact assessment includes the following: intake and brine impact, energy uses and emissions footprint, the positive and negative impacts of desalination, and the socio-economic impact. Most importantly for the desalination plant was limiting intake and brine impact. Intake impact was limited by the use of horizontal wells so as to avoid open ocean intakes. Brine impact was limited by the use of diffusers and a dilution tank. The following series of tables represents the potential adverse impacts and the possible mitigation measures that BAGG Environment discovered in the research of the North County desalination plant. Of these assumed potential adverse impacts, most important included the improper management of solid waste and the improper management of sludge waste, which can be mitigated by the development and implementation of a solid waste management plan, including recycling programs. Other possible environmental impacts included the improper care of raw chemicals and hazardous waste, which could be mitigated by implementing waste management plans and providing a designated container and areas for waste accumulation, along with proper disposal and worker training to deal with said waste. Concentrate discharge can be mitigated by rapid dilution design as well as diffusers into the ocean. The technology recommended by BAGG Environment will also produce clean water and mitigate the impacts of pretreatment backwash streams and the RO membrane cleaning solutions added to the concentrate. The technology used by BAGG Environment is considered to be very effective in producing clean water. BAGG Environment would like to thank you for your time today and let you know that the North County desalination plant is a feasible and viable option for the future of clean water in San Diego County. Thank you.